section 6 of chapter 2. Our topic today is proving angles congruent. Our objective is to prove and apply theorems about angles. So, for our first problem, we have a quilter who wants to duplicate a quilt that she saw, but she knows only the measure of two angles. And so you can see those two angles that she knows. She's got a right angle measurement here, and she has this one labeled as 60 degrees. And so, she wants to figure out the measures of angles 1, 2, 3, and 4. And so if we start to look at this, okay, trying to figure out the measures of these angles, I see a straight line going all the way up here. Which means that this big angle here and this angle here together form a linear pair. We know that linear pairs, the sum of linear pairs is 180 degrees, so this one we know is 90 because it's a right angle. This one's decomposed into a 60 and something unknown, this x. Well, 90 plus 60, that's 150, so 150 plus something is 180. It's the 30. So the measure of angle 1 is 30 degrees. We found our first angle. Well, if we look at this again with some more straight lines in there, here's another straight line going across. We know that this big angle and this little angle, this angle make a linear pair. And so if these are 60 and 30, we know this side is 90. Which means that this side, if we add it to that 90, we should get 180. Well, 90 plus what is 180? Well, 90 plus 90 is 180. So the measure of angle 2 is 90 degrees. So now we have to find the measures of angle 3 and angle 4. I see a horizontal line again. And it goes right here like this. I know that this one's 90 degrees. I found that out. So 90 plus something is 180. So I know that these two together are 90 degrees. Now, if I see another horizontal line there, right here, I see that red line I drew in there. I know the measure of angle 1 is 30, so I can put in a 30 there. And 30 plus 90 is 120. And if I add whatever the measure of angle 3 is, I should get 180 because all of those make a straight line, which means that the measure of angle 3 must be 60. And so if I know that 3 and 4 together make 90, I know that the measure of angle 4 equals 90 degrees. And there we found all of those, so we can actually read them. There we go. 1 is 30, 2 is 40, 3 is 60, and 4 is 90. So today we're actually going to learn some theorems that make this a lot easier to do. So, one of the relationships we saw in that is between vertical angles. We can prove this relationship using deductive reasoning. A theorem is a conjecture statement that you prove true. So we can use the given information, definitions, properties, postulates, and previously given theorems as reasons in a proof. So here we have a theorem. It says vertical angles are congruent. We have two angles, angle 1 and 3, which are vertical angles, and so they are congruent. And we have 2 and 4, which are vertical angles, and so they are congruent. So if we were going to write this as an if-then statement, we would say that we would need to first establish that they're vertical angles. That would be our hypothesis. So that would be our if. If two angles are vertical angles, then we can come with our conclusion. They are congruent. It's as simple as that. And so the hypothesis becomes the given that we're going to use in our statement and our proof below. So our hypothesis was two angles are vertical, and that's our given statement right here. Angles 1 and 3 are vertical angles, and that's what we're given in our proof down below. So you can actually fill that in. Let me just change my font size before we start doing a lot of writing. Alright, we're given that angle 1 and angle 3 are vertical angles, so this is our given statement. So we're going to go through and we're going to justify each of these steps for this proof. Okay, next one is 2. Angles 1 and 2 are supplementary, and angles 2 and 3 are supplementary. So how do we know this? We know this because the angles form a linear pair. Remember, angles that form a linear pair are supplementary. So angles that I should put the angles in there. Angles that form a linear pair are supplementary. Alright? And then how do we know that the measure of angle 1 plus the measure of angle 2 is 180? Well, once again, sum of the measure of supplementary angles is 180. Alright, so then we look down at step 4. It says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Well, we can say this because of the addition, because of the transitive property of equality. Up here we saw that measure of angle 1 plus measure of angle 2 is at 180, and the measure of angle 2 plus measure of angle 3 is 180, so we can substitute in the measure of angle 2 and measure of angle 3 for this 180. So that's by the transitive property. Which then we can say that the measure of angle 1 equals the measure of angle 3 because we subtract off that measure of angle 2, we get rid of it. So there we have our There we have our subtraction property. And then we get to our final statement. Angle 1 is congruent to angle 3 because we know that angles with equal measure are congruent angles. And there you have all the justifications for our proof of the vertical angle theorem. Alright, so let's do another one. Now that we've proven the vertical angle theorem, we're going to actually use it to find the value of this x here in this problem. We have that 2x plus 21 equals 4x. Well, remember, we just learned that vertical angles are congruent, so we can say that 2x plus 21 equals 4x. That's our original statement. Well, we don't have to justify this one, but we can talk about it. We want to get the x's together, and so we're going to use our subtraction property of equality to subtract 2x from here and subtract 2x from here. Get rid of those, we're left with 21 equals, 4x minus 2x is 2x. And then remember, we can use our division property of equality to divide both sides by 2. Divide by 2, and we get 21 divided by 2 should give us 10.5 equals x. And there you have it. 10.5 is x. So we use the vertical angles theorem to solve that problem. So I'm going to have you do here now is use the vertical angles theorem once again to solve for x. So pause the video and do that now. And there you have it, x equals 40. It's pretty simple work for that one. So we're going to now do a proof using the vertical angles theorem. So we're given that angle 1 is congruent to angle 4 in this drawing up above. So you can see, so we can, and then what we want to prove is that angle 2 is congruent to angle 3. So they gave us all the statements, and we need to fill in the reasons again. So let me just quick change my font size. There we go. Alright, so angle 1 is congruent to angle 4. That was the given that they gave us. So that's pretty easy. Angle 4 is congruent to angle 2. Why can we say that? Well, if you look in the drawing, you can see angle 4 and angle 2. We notice they're vertical from each other. So we know from the vertical angles theorem that those two are congruent. So we can say the vertical angles theorem. So it's not too bad so far. Now we look at our step 3. This angle 1 is congruent to angle 2. Why do we know that? Think about, okay, two angles that are next to each other. Look at they share this common straight line. What do we call those? We call those linear pairs. And so we know this one is we could say from them being linear pairs. We could also say we could use the transitive property because we know that 1 is congruent to 4 and 4 is congruent to 2, so 1 must be congruent to 2. So we're going to use the transitive property. So step 4 now is what we're on. In step 4 we have angle 1 is congruent to angle 3. Well, why can we say that? Well, look where they are in the picture. We have 1 and 3, and notice they're opposite, and we call that what kind of angles? Vertical angles. we know that vertical angles are congruent, so you can say by the vertical angles theorem once again. And then how do we then say that angle 2 is congruent to angle 3? Well, you look back up in the statements. We know that 1 is congruent to 2 and 1 is congruent to 3. And so if we use that transitive property once again, we can then say that those two are congruent because we can replace that 1 with either 2 or 3. We can say this one's by the transitive property as well. So there are a few different ways to do this. This is just one example of how we can do this proof. Depending on when you prove this when you prove this in order, you can use different theorems and different statements. So what I'm going to have you do now is you're going to use the vertical angle theorem to prove the following. You're given that angle 1 and 2 are congruent. What you need to prove now is that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. So pause the video now and see if you can figure out how to do that. Alright, you can take a look at my proof. I did angle 1 is congruent to angle 2 because it is given, and then I used the vertical angles theorem to say angle 1 is congruent to 3 and angle 2 is congruent to 4, and then use the transitive property to say that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3. Then I use the transitive property once again to make my long statement that angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. So that's how we would do that. If we, how could you prove this without the vertical angle? If we were going to prove this without the vertical angles theorem, we would have to use knowledge about linear pairs and right angles, knowing that, well, if we're given angle 1 is congruent to angle 2, we know they form a linear pair, which means they're both 90 degrees. And then we know that angle 1 and angle 4 form a linear pair, and if they both form a linear pair, we know they're 180 degrees for their sum. We know that 1 is 90, so 4 must be 90, and then we can continue to do that till we get them all established that they're 90 degrees, and then we could say that they are all equal, and so then they are all congruent. So that's how we would prove this without the vertical angles theorem. Alright, so the proofs we've looked at so far are two column proofs. There are other ways to write a proof. Another type is the paragraph proof. And so you just write in sentences like you would in another class. So here's that exact same proof, but written in sentences. It says angle 1 is congruent to angle 4 is given. Angle 4 is congruent to angle 2 because vertical angles are congruent. By the transitive property of congruence, angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3 because vertical angles are congruent. By the transitive property of congruence, then angle 2 is congruent to angle 3. And so there you have it. So the the vertical angles theorem is a special case of this next theorem down below. This is the congruent supplements theorem. And so what it says is that if two angles are supplements of the same angle, or if congruent angles, then the two angles are congruent. So we have angle 1 and angle 3 in this drawing below are supplements, and angle 2 and angle 3 are supplements, which then means that angle 1 and angle 2 are congruent. So that's the theorem. So we are now going to write a paragraph proof about that. We know that angle 1 and 3 are angles supplementary, and angle 2 and angle 3 are supplementary. So I'm going to just write that in the beginning of my proof. So angle 1 and angle 3 are supplementary. This is given. Angle 2 and angle 3 are supplementary. This is given. So we just start off with saying what's given, which is the easy part. And so if these angles are supplementary, we can then say that the measure of angle 1 plus the measure of angle 3 equals 180. And we can say this by the definition of supplementary. supplementary angles. And we can say the same thing for angle 2 and angle 3. So the measure of angle 2 plus the measure of angle 3 equals 180 by the definition of supplementary angles. Okay, so now that we have established that their sums are 180 degrees, we can then say that the measure of, so see how measure of angle 1 plus measure of angle 3 is 180, and measure of angle 2 plus the measure of angle 3 is 180? So what if we replace this 180 with the measure of angle 2 and measure of angle 3, since they're both equal to 180? So that we could say that the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2, measure of angle 2 plus the measure of angle 3, and this is by the substitution property. Substitution property. Okay, so we know that so far. And then if we look at that, our goal is to get that angle 1 is congruent to angle 2. So if we can get that the measure of angle 1 equals the measure of angle 2, we're there. So if we look at our statement now, here's our new statement right now. And we have that measure of angle 1 plus the measure of angle 3 is equals the measure of angle 2 plus the measure of angle 3. We've got a plus measure of angle 3 on both sides. So if we get rid of that from both sides, we can use the subtraction property to say that the measure of angle 1 equals the measure of angle 2. So we say the measure of angle 1 equals the measure of angle 2 by the subtraction property of equality. So now we have that the measure of angle 1 equals the measure of angle 2. And remember, if the measures of two angles are equal, that means that the angles are also congruent. So we can now say that angle 1 is congruent. And I can't do that congruent symbol, so I'm just going to write congruent to angle 2 because, or we could say that this is because angles with the same measure are congruent. And there you go, our final statement that we needed to get to is right here in bold. And we proved what we needed to prove, and we did it in a paragraph proof rather than in a 2-column proof. I hope you followed along with that. We're gonna skip this. You guys are gonna do enough of this in your homework. You're not gonna write a paragraph proof for the vertical angles theorem. So here are just some more theorems that are similar to the congruent supplements theorem. Here we know that the congruent complements theorem, it's the same type of idea but with complements. Two angles are complements of the same angle, or if congruent angles, then two angles are congruent. So angle 1 and angle 2 are complements. Angle 3 and angle 2 are complements, so 1 and 3 are congruent. Here we have the right angle congruence theorem. It says all right angles are congruent. If angle 1 and angle 2 are right angles, and they are, then they are congruent. And then we have theorem 2.5, congruent supplements are right angles theorem. If two angles are congruent and supplementary, then each is a right angle. So if angle 1 is congruent to angle 2, and angle 1 and angle 2 are supplements, then the measure of both of those is 90 degrees. So this is the end of section 6 of chapter 2 of geometry. I know proofs can be a struggle. I think you guys can do it. If you get stuck, let me know, and I am more than happy to help.